All right, here is the second half of the lesson. So these two problems are closer to the original example problem that I gave you. So we have this radical, we want to isolate it. Right now I have a minus n on the outside, so I'm going to do the opposite of that to move it over to the right. So now I'm here. So now that the radical is isolated, I'm going to square both sides. So negative 45 plus 14n equals n squared. My positive quadratic term is on the right, so I'm going to leave it there. And I'm going to take these things on the left and move them to the right by doing the opposite of each one. So that's a plus 45 and a minus 14n, and I want to do that to both sides. So on the left, everything cancels out, leaving me 0. And on the right, I have these three terms that I want to write in standard form. So the squared term first, then the n to the first term, and then the constant 45. So now that I'm here, I will start my cross method. What multiplies to 45 and adds to negative 14? And that is negative 9 and negative 5. So I'm going to write my factored form, n minus 9 times n minus 5. Set each of those factors equal to 0. Those are equal signs, by the way. And then, so that would be n minus 9 equals 0. I'm going to add 9 to both sides to solve. So n equals 9, and here n equals 5. So I'm going to check my math to see if those work. So plugging in n equals 9 to this equation gives me negative 45 plus 14 times 9, and that is 126. And then minus n, where n is 9. So I need to do negative 45 plus 126. Well, that's minus 45. So that is the square root of 81. And the square root of 81 is 9. So 9 minus 9 equals 0. So that's a check. And then I'll try 5. So negative 45 plus 14 times 5 minus 5 equals 0. 14 times 5 is 70. And then I need to subtract 45 from that. That is 25. So I have the square root of 25 minus 5. And square root of 25 is 5, and it is true that 5 minus 5 equals 0. So that checks. So this has two solutions. All right, so pause the video and try number 6 by yourself. I will say that it's like this one, except that the negative variable is written in front instead of behind, but you're still going to start the same by adding it to both sides. So go ahead and pause and then try that one by yourself. Okay, so you should have started by adding the k to both sides. So now I'm here. Square root of 4k plus 21 equals k. I'm going to square both sides. So that gives me 4k plus 21 equals k squared. And then moving the stuff on the left to the right by doing the opposite of each one. So everything here cancels. And I have 0 equals k squared minus 4k minus 21. So here's where I do my cross. What multiplies to negative 21 and adds to negative 4, that is going to be negative 7, positive 3. Set those equal to 0 and solve them. That's going to give you k equals 7 and k equals negative 3. So I'm just going to check those to see if they work. So plugging in 7 for the k's gives me negative 7 plus, and so here 4 times 7 is 28. And 28 plus 21 is 49. So that's positive 7, the square root of 49. So is it true that negative 7 plus positive 7 equals 0? Yes, that's true. So that one checks. And then I'm going to plug in negative 3. So right here, when I have negative k, that's the opposite of k. So k is a negative 3, so the opposite of that is a positive 3, right? If you want to see that written out, it's this negative is from the equation, and this negative is from the solution that I'm checking. So minus negative becomes plus plus. And then in the square root, I have 4 times negative 3, which is negative 12. Negative 12 plus 21 is 9, and that is 3. So is it true that 3 plus 3 equals 0? No. So that is not a solution. So just k equals 7 works. Then we have these 2 word problems here. Pause the video just to read it and understand the situation. So if an object is dropped, the time t in seconds that it takes to fall a certain distance d in feet is modeled by this equation. T equals square root of d over 4. Find the distance. All right, so find the distance. Oh, this must be an object. So find the distance. So distance is represented with d. So that's, if it's telling me to find it, that's my unknown. So that means the variable is going to stay a variable because I don't know what it is. So find the distance d, an object falls in 5 seconds. So now this is time. So that means t equals 5. So I'm going to plug 5 in where I see the t. Now in this situation, isolating the variable means undoing this division by 4. So far we've only undone things that were being added or subtracted. So here we have divide by 4. So to undo that, we need to multiply both sides by 4. So it cancels on the right, and on the left I have 20 equals the square root of d. So now that the radical is isolated, we are going to square both sides. 20 squared is 400. And we want to add units, so the problem tells us that the distance is in feet. So the answer is 400 feet. And then you pause and try number 8. So near Earth's surface, the speed of sound v is modeled by this formula. V equals 20 square root t plus 273, where t is the surface temperature. Find the temperature at which the speed of sound is 340 meters per second. So finding the temperature means we don't know the temperature, and it's being represented with a t. So t is my question mark. So that's important to know because when I go to plug stuff in, I'm going to leave t as a variable because it's my unknown. And we are given that the speed of sound is 340, and v represents that speed of sound. So I'm going to plug that in for v right here. So 20 times the radical t plus 273. Now this time, isolating the radical means we're going to divide because currently it's being multiplied by 20. So I'm going to divide both sides by 20. So 340 divided by 20 is 17. Equals square root 2 plus 73. So I'm going to square both sides. 17 squared. You might have to do some math over here. You do your math while I do my math. And it is 289. So on the right, the squared cancels out the square root, leaving me 2 plus 273. Now I just have to solve for t by subtracting. So t equals 16 and in degrees Celsius, so 16 degrees Celsius.